video we're going to be learning about completing the square. This is just another method to solve quadratic equations. So it's similar to extraction of roots or the square root property, but if we can't isolate the squared quantity or variable, we're going to go about completing the square. So here I have a quadratic equation in standard form, and as you could notice, if it's in a form like this or whatever, we can't isolate the squared quantity or variable. So in a case like this, we'd go about completing the square. So I'm going to go ahead and list the steps, and when we come back, we're going to go ahead and do an example. Okay, so I've listed out the steps that we're going to take in going about completing the square. So the first step is to divide the leading coefficient a. So if your leading term here has a coefficient in front or a number, we're going to just go ahead and divide that out. That's the first step. And I do want to point out that a, b, and c are all numbers, constants, and the x's are the variables. Okay, so moving on to the second step, we're going to go ahead and subtract the constant over, which is c. We want to get all the variables on one side and all the numbers on the other. And then the third step is to go ahead and take b, which is this guy here, the number in front of the first degree. We're going to multiply that by 1/2 or divide by 2, that's the same thing. And then we're going to square that. After you divide it by 2, we're going to square that whole thing. Okay, once you have that new term, we're going to go ahead and add that to both sides of the equation. That's the fourth step. And then the final step is just to solve for the variable at that point, because we get a nice binomial to factor, and yeah. So we're going to go ahead and do some examples now. Okay, so here's our first example. I had to erase the directions because we're working with the small board today, but I'll remind you as we go along. So the first step was to divide if there's a leading coefficient, so there's none in front of the leading term, so we're going to skip that. The second thing was to subtract over the constant, which was c, which is the 32, so let's do that. So then we get x squared plus 12x plus, and whenever I subtract the constant over, personally, I just leave a little space here, equals subtract the constant over, and then leave another space, because that's the term that's going to get added onto both sides. You'll see what I mean in a sec. So the third step was to take b, which is 12 in our case, divide it by 2, or multiply by 1/2, and then square that. That's what I'm going to add onto both sides of the equation. So I'm going to take 12, which is b, divided by 2, and I'm going to square that. So then that's going to be 6 squared, so then that's going to be 36. So that's what I'm going to go ahead and add to both sides of the equation. So we put a 36 here, and a 36 here. So this will always factor as a nice binomial whenever you complete the square. So this is like x plus 6 squared, right? And then over here we get 4. Okay, so now we're on the fourth step, I think. I don't know if I was keeping track with the directions, but we're just going to go ahead and solve for a variable x now. It's this looks very similar to extraction of roots, and completing the square does lead down to that route. So it's just pretty much like an extraction of roots or the square root property type at this point. So we're going to square root both sides. So then we get x plus 6 equals plus or minus 2. You have to account for the roots, right? So then we get x plus 6 equals positive 2, and x plus 6 equals negative 2. So then we just subtract the 6 over and we get our answer. So we get that x is equal to negative 4, and we also get that x is equal to negative 8. So for the first example, those were my answers. So we're going to go ahead and do more to get a feel of this. Alright, so why don't you guys go ahead and give this a try, and then I'll go over with you. Alright, so assuming you gave that a shot, the first step is to look for the leading term to see if it has a coefficient, which it doesn't, so we're skip that step. Second thing was to subtract the constant over, which was c, but it seems like they already did that for us, so we're just chilling so far. Now the third step was to take b, half it, and square it, and add it onto both sides. So our b is -10, so we're going to take -10 divided by 2, and then square it. That's what's going to get added onto both sides, so we get -5 squared, and that's 25. So 25 is going to get added onto both sides. So then we get x squared minus 10x plus 25 equals -24 plus 25. This will factor nicely, so you get x minus 5 squared, and this will just be 1. Now it's just like extraction of roots, so we're going to take the square root of both sides. So we get x minus 5 equals plus or minus 1. So we come off over here and we get that x minus 5 is equal to positive 1, and x minus 5 is equal to negative 1. So our two solutions turn out to be x equals, add the 5 over for both, so you get a 6, and you get a 4. So this is it for the second one. Alright, so third example, I'm going to go ahead and do this one. So the first step and the directions for all of these are to solve by completing the square. So the first step was, if your leading term has a coefficient in front, you want to go ahead and divide that out first, which mine does. So divide everything by 2. I meant divide it by the whole equation for that first step when I said divide it out. So then we get x squared minus 2x equals 5. Now our second step was to subtract the constant over, which was c, but they already did that for us. So then we move on to the third step. Take b, which is -2, divide it by 2 and square it, and then add it to both sides of the equation. I know that sounds like a lot, but it's really not that bad. So our b is -2, divide it by 2, and then we square it. So then we get -1 squared, so then we get 1. So that's what we're going to add to both sides of the equation, is 1. So then we get x squared minus 2x plus the 1, and then it equals 5 plus that 1. This will always factor nicely. So this will be x minus 1 squared, and this will be 6. Extraction root type at this point, so square root of both sides, square root. So then we get x minus 1 equals plus or minus the square root of 6, because there's nothing in there to take out. So then we get x minus 1 equals a positive rad 6, and then we get x minus 1 equals a negative rad 6. And if we just added the 1 over, we'd be done. So we get x is equal to rad 6 plus 1, and we get that x is equal to negative rad 6 plus 1. So that is it for the third one. It was the type where we had to divide the leading coefficient off the leading term. So we're still going to move along and do some more.